Today we're looking for a solution to a fifth degree congruence, and it's not in I'm looking for a solution that's not in the least residue system. Now notice the modulus here is 23. So 0 to 23 would be, wait, should that be 22? Yeah, that should be 22, I guess. Yeah. Sorry, that should be 22. So this would be a modulo 23. The possible remainders are 0 through 22. Okay, so but I'm looking for something in the next highest one, whatever they call that, number theory. Okay, so again, notice this is a fifth degree congruence, which is a little bit larger than some of the ones you see in the introductory number theory textbooks. And what I'm going to be using today is something called the Legendre symbol, which I don't know a whole lot about. I do know it's related to quadratic reciprocity and finding solutions to second degree congruences. And you got this strange controversial symbol here. Let me just show you what I'm doing here with this symbol. And again, this is not intended to be a complete development of the Legendre symbol. It's a symbol used, it's trivalent. If P divides A, then it's equal to 0. If this symbol is equal to 1, that means there is a solution to this congruence mod P. If it's equal to -1, that means there's no solution. Now, it turns out, due to number theory results that I can't prove, or I don't particularly understand that well, the symbol 3 over P is equal to 1, it turns out, for prime numbers that are congruent to 1 or 11 mod 12. Okay? And so this implies that this guy right here has a solution because, of course, the reason is 23 is congruent to 11, right? 23 is certainly congruent to 11 mod 12, right? So it's two different modulus working here to help you determine when you have solutions or you don't. Now again, this only tells you it has a solution. It doesn't tell you how to find the solution, but at least there's hope because you would have to check 23 numbers, right? 0 through 22. It turns out 7 squared minus 3 is equal to 46, okay, which is a multiple of 23, okay? That's equal to 2 times 23, right? So, as the Legendre symbol predicts, we do have a solution, namely 7. This implies that x squared is congruent to 3 mod 23, right? So we can write down x equals 7 as the solution, right? Okay, so that's good news because, and again, you may be wondering what's going on. You can factor these congruences just like you can factor regular real numbered equations. So I factored out the x squared, but we know for this particular modulus that x has to be 7, okay? 7 squared is congruent to 3, all right? So what we can do right here, and this is fairly straightforward, let me just write this down. This would be 3, all right? And now we have, and I'll write this carefully, x cubed, right? But that would be, well, let's just write it down. Okay, x cubed, just one step at a time, plus 6 plus 11, right? Fair enough, right? All we did was use our little discovery here without showing too much work, right? We do know from the Legendre symbol and this discovery right here that x squared is congruent to 3. So I simply replace x squared with 3, all right? Now let's keep going here. Okay, so now you have 3, okay? Now here's where you got to be slightly, well, it's no big deal. Okay, we know that this is x squared times 7, right? So this would be 3 times 7 plus 6, right? Remember, x is 7, x squared is 3, so we can write this down. Right? So far, so good. So what does that give us here, folks? This gives us, this is 3 times 7 is 21. 3 times 7 is 21. 21 plus 6 is 27. 81. So this would be 81 plus 11 is what I'm getting, ladies and gentlemen. Okay, but y'all, you can see manifestly that's congruent to 0. Congruent to 0 mod 23. Okay, mod 23 is understood right here. It's mod 23. Mod 12 is involved in helping us out in the problem, but mod 23 is the modulus of the original equation. That's congruent to 0 simply because this is 4 times 23, right? And 23 is congruent to 0. Okay, so 7 is a solution, but it's not a solution in this set, right? X is equal to 7, but also any other solution. Okay, it's equal to 7 plus any multiple of 23. We could call it 23n if you want. And so if n is 1, okay, this is equal to 30 whenever n is, just for n equals 1, right? So there's an infinite number of solutions. 7 was the least residue, I think they call it. But 30 is in this set. So this is the answer we're looking for, ladies and gentlemen, 30. All right, again, I'm getting used to the Legendre symbol, and I wanted to have an example of where it might be useful, or you might want to try it. It's still like a little bit of a needle in a haystack, these type of equations. They have to be designed, which I designed it to work out nicely. But we did solve a 5th degree congruence.